Well, good afternoon and welcome to you all, and a very warm welcome to isifundi Training and our 2024 Bite-Sized Corrosion Summer School, where we're going to be talking about cathodic protection in hazardous environments. My name is Vanessa Seeley Fisher, and it is really my great pleasure to host you. Just a quick summary of what we try to do in every session of Bite-Sized Corrosion is that we try to break down an aspect of corrosion-related information into what we hope are interesting and informative nuggets. And we hope that by the end of the session, you'll feel that you leave us having learned something new and eager to continue your own journey in understanding corrosion a little bit more. We are starting a brand new 6-session series today where we look at the use of cathodic protection in hazardous environments. And throughout the series, we're going to be considering some of the challenges associated with cathodic protection in the hazardous environments. We'll look at some of the design considerations that need to be taken into account. And of course, given where they're installed, there are obviously some inherent risks, and we'll be exploring a few of those in some detail. And then as our series draws to a close, we're going to be looking at how we can best monitor the effectiveness of cathodic protection systems in these environments. And we'll be looking at a few case studies to highlight some of the do's and usually the don'ts as well. Now, as we kick off today, we thought it would be appropriate to explore a little bit more about what we mean by hazardous environments. And I'm delighted to be joined by Neil Webb to expose this topic a little bit more. Now, Neil is well known to most of us, and I know he's often fondly referred to as Mr. Cathodic Protection South Africa. And in light of that, Neil, I know we're going to learn a lot from you today. So thank you for joining us.
Thanks, Vanessa. Yeah, my experience with cathodic protection in hazardous environments actually stretches back almost 40 years to the day, in that I got called in to help sort out some issues at the Sasol plant in Secunda in the early 1980s. And that was the start of my journey in terms of taking this cathodic protection principle and applying it across a number of things other than water pipelines, which is where I first started.
Thanks, Neil. And I know that we're going to learn so much as we explore this. But I think maybe the first place we should start is with, if I can term it a definition, what exactly do we mean by hazardous environments? And if we consider the terminology in a risk analysis, where a hazardous environment is an environment that is likely to cause damage, obviously we can see the parallels with the petrochemical industry, where we've got perhaps environmental risks from leaks and explosions. Your thoughts on that?
And the hazardous environment in this situation is any environment where it is possible to have a fire or an explosion. And these, of course, as you quite rightly say, are associated primarily with the petrochemical industry. And those of you who've done maintenance work perhaps on old vehicles will know the challenges associated with trying to repair an old-fashioned metal fuel tank, where you think you've cleaned it out, gotten rid of all the old petrol, and you start to solder or otherwise seal a leaking joint on an old tank, and all of a sudden, bang, there was some residual gas, or fumes in this case, from the petrol. And of course, we need to realize that the problem is that whether you have a liquid or a gas or even a solid, you can generate a mixture of that material with air, with oxygen, which can then ignite. And that is then the definition of a hazardous situation. I can't remember how many years ago, maybe even decades ago, there was a fire or an explosion at a flour mill in Johannesburg, where the dust from the flours was ignited by a static discharge. And I know in the granary industry, for example, you see grain silos all over the place. You can get huge static built up by the transport of grain through pneumatic conveyors, for example. And so they have to be particularly careful as well to ensure that you don't get sparks, because that dust will ignite. And for those of you who want to be explosive experts in your youth, you may well have made flour bombs where you can blow up flour by using a candle in a tin. But anyway, that's got nothing to do with cathodic protection. So let's carry on with that aspect of it.
As you rightly say, when we think about hazardous environments, I suppose the one with which we're all mostly familiar would be our local refueling station. And I know I'm guilty. There are signs all around them, which often get ignored, which say no cell phones. And maybe that's something we should explore a little.
Well, absolutely. The challenge with cell phones, and I'm sure all of you are familiar with the thing that happened a while back where a particular brand of cell phone was banned from being carried on aeroplanes because the batteries, they were lithium-ion batteries, and lithium-ion batteries are notorious for misbehaving if they're not treated properly. And you may think, oh, it's only just a small battery. But those small batteries pack a powerful punch. And if they are mishandled and they go off, they can deliver a significant charge, electrically speaking, to the extent that they can cause a fire. This risk then is really associated with the probability or the likelihood of causing a fire as a result of an electrical spark, which can come from lightning, it can come from static, it can come from your car battery if you disconnect it. It can come from your cell phone if your cell phone is plugged into a charger that's not properly regulated. If you leave your cell phone sitting on the dashboard of the car and it gets overheated, all those sort of things can cause this problem. And in fact, our own local fuel station around the corner, well, I don't know how long ago it burned out, and that was due to a spark.
Okay, so now you've raised a question. Cathodic protection requires current, transformer rectifiers, potentially sparks. And now we're talking about cathodic protection in hazardous environments where we don't want sparks and we don't want to cause problems. How do we connect the two together in very broad terms? Because I know we'll get into it in a little bit more detail later in the series.
Well, there are a couple of ways of addressing it, which we're going to come to in more detail in the section of design. But essentially, the hazardous environment industry is regulated by a set of codes called the EX series. So you get EX.E, EX.D, EX.I, and so on. And all of these are things that stand for increased safety. Right. And there are various mechanisms for achieving that. You can take an ordinary rectifier and you can put it in an oil bath, for example, so that there's no chance of a spark. You can put it in an explosion-proof cabinet, like, and bolt it down with 1,000 bolts, which makes your maintenance life very difficult. Or perhaps you could go for sacrificial anode cathodic protection, because then you don't have the energy levels that are necessary to cause this incendiary sparking, which is the challenge that we are faced with.
So having ascertained that cathodic protection won't be a complete disaster in our hazardous environment, I suppose a real valid question is to say, why do we want to use cathodic protection in these hazardous environments anyway? I mean, we've spoken already about a little bit of difficulty, but what benefit is there to using cathodic protection within these environments?
Well, of course, the challenge with these environments is that the products that are being processed are risky in terms of environmental damage if there is a leak, or if you get a leak and you subsequently get a fire, which can have absolutely nothing to do with cathodic protection, or you could get a gas leak and you get an explosion and so on. So the challenge really is that the integrity management of these environments is critical. And cathodic protection is one of the ways of ensuring the long-term integrity of your infrastructure. Now, whether that infrastructure is tanks or pipes doesn't make any difference. Anything that is likely to corrode, we need to prevent that corrosion. And cathodic protection is a very, very effective way of preventing corrosion.
So in some ways, very careful during the design process, very careful consideration of the risks, both for using and not using cathodic protection would probably be very wise to ensure that we do keep our assets fully maintain their integrity.
Mm-hmm.
And Neil, if we think about where we use these, we started off with our local refueling station, but actually we would find these hazardous environments where cathodic protection can and is implemented in places like tank farms and refineries, depots where there may be just a couple of tanks. Where else? Maybe piping in tank farms?
Well, you can't have a tank farm without some way of getting the product in and out of the tank. And so therefore there is always going to be piping associated with the tanks. That piping is generally known as breakout piping. It's the piping that takes the product either to the tank or from the tank, and it'll take it either to a loading bay or come from a pump or something like that. This breakout piping is often above ground, but it may well be buried. And so you can get buried piping associated with the tank farms. The other aspect of that, of course, is that in the risk management of these installations, you always have very complex firefighting systems. And usually those are below ground, because that way your firefighting system is protected from the fire. If your firefighting system was above ground, it's going to be affected by the fire. So a lot of the firefighting systems are below ground, and there you now have got piping that is below ground, and it is one of the standard applications of cathodic protection is to protect buried piping against corrosion.
And of course, when I talk about tanks on these tank farms, cathodic protection can only be applied to buried or submerged infrastructure. And I think we've emphasized that for the duration of doing bite-sized corrosion. We can't apply cathodic protection to above ground structures. And a lot of these tanks are above ground. So when we talk about protecting the tanks in a tank farm, let's explore what we actually mean by protecting the tanks.
Well, that of course depends very much on the style and design of the tanks. The most common tanks that we are familiar with, because those are the ones that we see, are those that are known as AST, an acronym for an above ground storage tank or an on-grade storage tank. And that typically is a vertical cylinder, but the base of that cylinder is sitting on the ground and is in contact with the ground. To all intents and purposes, it's buried because of that ground contact. And it is a very difficult environment to protect against corrosion because you get moisture ingress between the base of the tank and the whatever it's sitting on, and you can get air going in there. When a tank gets, particularly some of these big tanks, which are maybe even 100 meters diameter, in the very, very big tanks. When those tanks get emptied, the floor moves and flexes. So you get air and moisture drawn in and expelled and so on. They're anaerobic environments, which makes them very susceptible to bacterial corrosion. If you have tank farms adjacent to the coast, which often happens because all our products get shipped by tanker, and the easiest place to store the material on land is in tank farms adjacent to the coast. So not only do you have air and water drawn in underneath these bases, but you've got the effect of marine environments, the salt contamination. Now, granted, it's not as bad as actually going offshore, but you still get a pretty aggressive environment in that situation. So those are the above ground storage tanks. But then you also get smaller tanks, which are completely buried. These are typically horizontal cylindrical tanks, and they are buried with the top of the tank maybe a meter below ground. And there you have an ideal situation from a corrosion point of view, in that is going to corrode. Okay, you can coat the tank, but how long is the coating going to last? And so there we have a situation where cathodic protection is particularly effective for those underground tanks as well.
Now, Neil, the other kind of tanks, which are bizarre because they are buried but not buried, of course, are your mounded tanks. So your particularly LPG bullets, which are constructed above ground and then buried by being covered in soil. And those also, effectively, you've created a corrosive environment around them. And cathodic protection can work.
Yeah, those mounded situations are actually quite hazardous from a corrosion point of view
Mm.
because there is now a significant gradient in the oxygen content
Mm.
of the mound. The base of the mound will have relatively little oxygen. The top of the mound is well exposed to air and water and so on. And so you get quite a significant corrosion gradient or oxygen gradient, aeration gradient, whichever one you want to call it, between the top and the bottom of the tank, or the bullet in this case, if it was an LPG tank, which can set up the corrosion process. And yes, it is possible to provide those mounded structures with cathodic protection. And we'll have a look at some case studies in that regard when we get to the end of the discussion.
It's interesting. I was doing some research on it a little while ago, and that the mounding is there primarily for safety, particularly with the LPG. And yet, by mounding it for safety, they've created another risk. And again, that goes back to this risk comparator of when you mitigate a risk, sometimes your mitigation brings in another risk, and that also needs to be considered. Now, Neil, one of the challenges that we encounter with the small sort of fuel station scenario is that they do have buried tanks, but if I'm not mistaken, they're not always steel. Would I be correct in that?
Yes, most of the tanks that have been installed in recent years are what are often referred to as composite tanks. So it is a steel tank for the structural integrity, but these tanks are both lined and coated with fiberglass. And that's a really heavy duty coating system, which effectively completely insulates the steel from the environment. And those tanks are not cathodically protected. There's just no point. It's not necessary. Unless there was mechanical damage to the extent it did damage the fiberglass. But if that had happened, you probably would have had mechanical damage to the tank, which would have required other intervention anyway. So generally, the composite tanks would not be a candidate for cathodic protection. And the other thing that happens with fuel stations in particular is that a lot of the service piping from the buried tanks to the bowsers and so on is also plastic. You can't protect those pipes. There are other aspects of that piping which is quite interesting from a hazard reduction point of view. And that is that it's not just any plastic pipe, because if you transfer fuel through a plastic pipe, you generate static. And you may wonder why the bowser of your fuel station has a metallic spout. It is so that you cannot draw an arc between the spout and the car. And so the pipes that are used to transfer fuel are made of special conductive plastics or rubbers in order to prevent the buildup of the static.
Okay, that's very interesting, especially after our discussion about static and fuel stations a little earlier. Now, I know in this series we're going to primarily focus on the tank farm type scenario, and we spent a lot of time talking about cathodic protection of pipelines, and obviously a fuel pipeline could be deemed hazardous, but it's just a pipeline. But when we think about our tank farms and our depots, we don't think of these big pipelines necessarily. Maybe that's our delivery mechanism. But there is also, as we've spoken a little bit earlier, the breakout piping. Some of that is buried, if I'm not mistaken, and then that would also need cathodic protection.
Yes, and that would need to be considered. And the other aspect is where these large-scale fuel delivery pipelines come into the depots, there's going to be an interface. So you may well have a cathodically protected bulk supply line coming into a depot, and then that has to interface with the piping, the pumps, the tanks, and so on in the depot. And that interface is also a point of concern from a safety aspect. So in that regard, if you think you've got a large diameter fuel pipeline coming into a depot, usually with an insulating flange at the entry point, all the piping in the depot is now well earthed, and we're going to talk about that challenge of earthing versus cathodic protection. Your fuel pipeline incoming is sitting at cathodic protection levels. And if you short out that insulating flange, you could easily draw a spark. Or if you get a lightning strike in the area, you get a transient on that pipeline, which can draw a spark. So surge protection forms a large portion of the integrity management of a hazardous installation when it comes to piping. Whether you've got cathodic protection or not, you need to have that sort of protection in place.
And we'll talk about that more tomorrow. As we draw to a close, I just want to talk about fire water systems, because they're often like if I can say, the Cinderella of the system. They're so often ignored or forgotten about. Yeah, exactly. And the challenge that I see often with these fire water systems is that they're often, although they're buried, they may not be steel, or sometimes they don't know whether it's steel or plastic. And that can be quite a challenge when it comes to cathodic protection and the risk of corrosion, specifically, rather than sort of hazards.
Yes, the tendency, if I can put it that way, these days is to install the buried section of the fire water main in plastic and then have steel hydrants, which then come up above ground. And you obviously can't have plastic hydrants above ground in a fire situation. And these hydrants then are really a double whammy, because firstly, they're not part of the overall CP system of a depot, if that depot is provided with CP, and therefore are susceptible to current that may be floating around in the soil as a result of a CP system. And secondly, a hydrant that goes from below ground to above ground represents an ideal corrosion situation, because you've got the interface, which often includes concrete encasement, and the net result of that is that you get bimetallic and differential aeration systems set up, and you'll land up with corrosion of the hydrant around the base of the hydrant, where it may not be very visible. And just like the classic situation of the lamppost and the dog, the lamppost will corrode and break at ground level.
Yep.
So too will your hydrants, if they are not looked after properly. And there are ways to deal with that.
Yes.
It's not necessary. But unfortunately, what we find is that very often the operators haven't got a clue about what their fire system comprises and even where it runs.
Yeah.
It's quite disturbing from the work that we've been doing on depots. There's a lack of knowledge or awareness of what's in the ground.
Yeah, no, that's true. Thank you, Neil. I think it's been helpful to define what we mean by hazardous environments and where we're going to take this discussion in the next couple of sessions. And I think that we can all anticipate that work conducted within the petrochemical industry is likely to be risky. And of course, we'll be looking at that. And I would like to invite all our guests today to join us again tomorrow, when we're going to delve a little deeper into some of the challenges we've alluded to already about with wanting to use cathodic protection in tank farms, some of the things that need to be taken into account that aren't always first sort of front of mind when we're thinking about CP. But if you want to find a little bit more information on cathodic protection, we'd like to invite you to consider to take our online course, which we've titled CP 101. And in this course, we delve a little deeper into the concepts of cathodic protection. And that information is available on our website. And while we're doing the little advertising thing, I'm going to invite you to join us or follow us, I think is the term, on Instagram, on LinkedIn, on TikTok, and that'll keep you updated with what we're up to. Thank you.